Alrighty, we're going to do limits at infinity. So I'm going to take the limit as x approaches infinity of this. When I plug an infinity in, I will get infinity over infinity, which is called indeterminate. Since it's indeterminate, I now need to rewrite the function so that I can plug in infinity. And to do that, I take the highest degree in the denominator. The highest degree in the denominator is x. So I'm going to divide the top and the bottom both by x. So here's what it's going to look like. I have the limit as x approaches infinity of 4x divided by x minus 2 divided by x all over 3 divided by x minus x divided by x. So if I lost you there, I divided each piece on top by x and each piece on bottom by x because the highest degree in the denominator was x. What I now have is the limit as x approaches infinity. If I reduce each of these, that's what I'm going to do now. I'm going to reduce those. The first one becomes 4. The second one stays 2 over x all over. The bottom left is 3 over x. And the bottom right is x over x is 1. So right there is a simplified version or a different version of this. This, and this are all the same. Except what's nice about the red here is I can now plug in infinity and find the value. Okay, it's an analytical way of finding a limit. We had to rearrange it first. So now, when I plug in infinity, that would be 4. That would be 0. 3 divided by infinity is 0 minus 1. So the answer is 4 minus nothing over nothing minus 1. Again, this is 4 when you plug in infinity. 2 divided by infinity is 0. 3 divided by infinity is 0. And negative 1 stays negative 1. So that becomes 4 over negative 1. So my value for this limit is negative 4. So for this one, when I plug in infinity, I get another infinity over infinity. So that's called indeterminate. So I now have to divide top and bottom by the highest degree in the denominator. The highest degree in the denominator is x squared. So what I have now is the limit as x approaches infinity. I'm going to take 5 and divide by x squared minus 3x divided by x squared all over x squared divided by x squared minus x over x squared. Next, I'm going to simplify that. Okay, keep the limit going. All right, this piece, the first piece, this is going to stay the same. Won't this become, looks like 3 over x? This will become 1, and this will become 1 over x. So, that's a limit right there. We're going to have, again, 5 over x squared minus, I think it was 3 over x, 1, and 1 over x. All I did is simplify each one. Now, all 3 of these are the same, but this one I can plug infinity into. So when I plug infinity, I get 5 over infinity is 0. 3 over infinity is 0. That's 1. And 1 over infinity is 0. So I have 0 minus 0 over 1 minus 0, which becomes 0 over 1, which is 0. My answer is 0 to this limit. So for this last limit, when you plug in infinity, you get infinity over infinity, indeterminate. Then, so I'm going to divide by the highest degree in the denominator. So x is the highest degree in the denominator. So I have the limit as x approaches infinity of 5x squared over the x, which is the highest degree in the denominator, divide by x, 2x divided by x, plus 3 divided by x. Now I simplify this. The first piece is going to be 5x minus x over x is 1. And then we 2x divided by x is 2 plus 3 over x. Now, let's plug in infinity to this new piece, which is another version of this. And what you'll notice is we'll have infinity. 5 times infinity is infinity, minus 1, over 2 plus 0. So look at that real quick. It's kind of weird. You're going to have infinity minus 1 over 2 plus nothing. Now this is a little confusing, but if you have infinity and you take away 1, it's still infinity. Over 2, so half of infinity, it's still infinity. That's still going to go on forever. So what that's saying is it's just the answer goes on forever. So when you take this limit, it's saying it's going up forever, getting bigger and bigger forever, big.